Hi everyone. So today, right now, we're going to take a look at this problem that we discussed yesterday in class, but now I'm going to work out the details, and then also in a later video I'll show you how to use technology to solve some of these problems. Okay, so the problem we have right now is it's on this activity, which is also on Canvas. Okay, so if you go to the week 8 module, you can find a blank copy of this handout as well as the solutions we covered on Monday. Okay, so what we're on is example number 3, and this is that company Soundex. They produce 2 models of satellite radios. Okay, Model A requires 15 minutes of work on assembly line 1. Model A requires 15 minutes of work on assembly line 1 and 10 minutes of work on assembly line 2. Model B requires 10 minutes of work on assembly line 1 and 12 minutes of work on assembly line 2. 25 hours of assembly time on line 1 and 22 hours of assembly time on line 2 are available each day. Soundex anticipates a profit of $12 on Model A, $10 on Model B, and because of previous overproduction, management decides to limit the production of Model A satellite radios to no more than 80 per day. Okay, so I know it doesn't say it in the question here, but ultimately we're trying to optimize, we're trying to maximize the profit subject to the constraints. Okay, so there's kind of maybe 3 or 4 steps to doing these problems. We got to figure out our constraints, our objective function, which is the function we're optimizing. In this case, it's profit. Okay, and then we want to graph the feasible region corner points and determine which corner points maximize the profit. And part C is going to be the part that takes a while to do. So we're going to flesh out all the details right now. Okay, so as we said yesterday here, the objective function is our profit function. Okay, so this is profit here. And then we had a lot of constraints. Okay, so what I recommend, but you don't have to do this, is to make a table of the constraints like we did yesterday. So we did that on the Google Doc, but I'm going to do them again right now just to be thorough here and complete. And so I'm just going to make a sort of 4-column table here. Okay, so, and we have some rows here. So the rows are going to be which type of radio, or I'm sorry, which assembly line. Okay, so assembly line. So this is assembly line 1, okay, and then this is assembly line 2. Okay. Okay, and then we have Model A here, and then Model B here. Okay. So we got 2 types of radios, A and B, and then we got 2 lines, 1 and 2. Okay, and each radio takes a certain amount of time on the assembly line for whatever reasons. Different models need different. Assembly line 1 might be like the components and the electronics, and assembly line 2 might be packaging. So Model A might be a smaller model and needs less time here. Less time on assembly line 1 than on assembly line 2 or something like that. Okay, you can imagine if you will. Okay, so we filled this table out, and what we ultimately wrote down was, okay, well, it needs 15 minutes here on assembly line 1 and then 10 minutes on assembly line 2. Okay, and then Model B needs 10 minutes and then 12 minutes on assembly line 2. Okay, And these are right now, these are all minutes. So if you want to be concise, we should just write minutes here. Okay, so now, okay, so actually model B is probably the smaller one because it takes 10 minutes on assembly line 1. Okay. Anyway, the other thing that we wrote down yesterday was the available time. Okay, so the time available. So, okay, so, and in here it says we have 25 hours available on assembly line 1. So we have 25 hours. But if you remember, we multiplied by 60 to get everything into minutes. Okay, so we multiplied by 60 here. So 25 times 60, that's 1,500. Okay, and then 22 hours available on assembly line 2. So 22 times 60. Okay, so, and I don't remember what that is. I think it's 1320. Okay, so I should find a calculator so I can do some of these calculations. Okay, good. And these are also in minutes. Okay, this allows us to now set up our constraints. Okay, well, the Model A radios. Okay, the Model A radio requires this much time, and the Model B requires this much time. But then we only have this much time available for assembly line 1 and this much time for assembly line 2. Okay, so even before we start here, what I should have just written down, I forgot to write this down, is that we want to translate the problem into variables. Okay, so it's important that every time we do, oh, it looks like I froze in the corner there, so I didn't, okay, so that's a little funny. Every time we do a word problem, we want to translate our problem into variables so then we can use algebra to do the math. Okay, so here, as we did yesterday, x is going to be the number of Model A radios. Okay, and then y is the number of Model B radios. Okay. Okay. Okay, so I'm going to pause for a second to see if I can fix this video here. Okay, we're back. I just got rid of the video, so sorry, you won't see my face. So x is the number of Model A radios, and y is the number of Model B radios. So really the question is, okay, what I should put in front of what we want to do here is what is x and y, or how many radios should this company produce to maximize profits subject to the assembly line constraints. Okay, so I'm going to put in some words here. Additional words. So I'll just use I'll use green. Okay, so what is x and y? Okay. Okay, so let's use lowercase y here. Okay, so we can maximize profit subject to the assembly line constraints. So I'll write that in red, assembly line constraints. Okay. So this is the question here. Okay. So what is x and y so we can maximize profit subject to the assembly line constraints? And there's also some other constraints as well. Okay, so now to write down the constraints, we have several constraints here. Well, this is how much time is available on assembly line 1. Okay, so if we make x Model A radios and y Model B radios, what we need is that 15x plus 10y is less than or equal to 1,500. Okay. And same thing with assembly line 2. If we make x Model A radios and y Model B radios, well, we need, 10 times x minutes to do the Model A radios, and then 12 times y for the Model B radios. And combined, this is the time available, the time it takes to make these radios on assembly line 2, that needs to be less than the time available, so less than 1320, okay? Okay, so it's a good idea to think about what's going on here. The left-hand side is the amount of time it takes on the respective assembly line to create X radios, X Model A radios, and Y Model B radios. And then the right-hand side is the time available here. Okay, so some things to think about here. Okay, there's also some other ones. The management decided to limit production of Model A radios to no more than 80 per day, so we can only make at most 80, no more. Okay, and then you also have some freebie linear inequalities that come for free, and especially with these word problems, at least in this specific one, we can have that x is greater than or equal to 0 and y is greater than or equal to 0. Okay. Okay, so this is our list of constraints here. So this is the answer to letter A here. Okay, so these are our constraints here. Okay. Now we're going to continue, and we'll do part B. We want to write down the profit function. Now this is not too bad to see, knowing that we have our variables. Okay, so remember, it's important to write down what you're looking for. You know, what you're looking for, how many radios do you want to produce in terms of variables, and then you can write things now using algebra. In algebra, our profit function is just P. Okay, well, let's see. They anticipate a profit of $12 on Model A and $10 on Model B. So this will just be 12x plus 10y. Okay, so that's this here. Okay. Okay, so again, what we are trying to do is we're trying to maximize the P. Okay, we're trying to maximize P here, subject to these constraints here, subject to these constraints. Okay, so certainly, as I said yesterday, you could just make one radio of each, one Model A and one Model B, and that will get you, I think we said $22. Okay, so if you could just make, you know, P of 1, 1, this is just 12 times 1 plus 10 times 1. This is $22. But that's not going to be a lot. That's not going to be the most. Okay. So we want to figure out how many radios to make the most. Okay. So as I said yesterday, and I'll show you kind of the notes here that we took yesterday, but then there'll be some better notes uploaded later on. Okay, so here we go. What we want to do is we found the objective function and the constraints here. So we found the objective function and the constraints. We want to graph the constraints and find the feasible set, the solution set. And then we want to use the fundamental theorem of linear programming to find the possible maximums and minimums. The fundamental theorem of linear programming, which is on page 116 of the book, says that the maximums or the minimums of the objective function is achieved at one of the vertices of the feasible set. Once you find those, and you have to use some algebra, we're going to check the maximums and minimums using the objective function. Okay, so we have some things to do here. We have to graph, and then we have to use the fundamental theorem of linear programming, and then we have to check maxes and mins. Okay, so here we go. Okay, so first we're going to graph this region, and we started doing this yesterday, but now I'm going to try to do this a little bit better now. Okay, now I'm going to take a second and just zoom in here. Okay, and I think what we did yesterday is we labeled our axes by 20s. Okay, I think we did 20s, or maybe did we do 100s? I think we did 20s. Yeah, let's try 20s here. So 20, 40, 60, 80, 100, 120, okay, 140, and 160. Okay, so that should be enough. And then we'll also go this way as well. Okay, so 0, 20, 40, okay, 60, 80, 100. So I apologize if the worksheet is a little bit faint on the lines here, but there are some extra lines available here on canvas if you need to. Okay, so it looks like I might have messed up the 20, so, whoops, 0, 20, 40, 60, 80, 10, 12, 14, 16, 80. Okay, so it just looks weird to me, that's why. Okay, okay, so let's start by graphing some of these lines first. So there's the easy ones we don't have to really draw here. So these ones here, x greater than 0 and y greater than 0, we don't really need to draw that. But what we can do is graph these ones here, okay, and then we'll see the feasible set. Okay, so the reason why we don't have to graph these, the x greater than 0 and the y greater than 0, is because they're just given by the axes. Okay, so maybe I'll just draw on the axes just to be clear. This is our y-axis here, okay, and then this is our x-axis here. And the solutions for these model radios, you have to have all of them positive. So the solution will be in the positive quadrant here. Okay. Okay, so now let's try to get the answer here, or sorry, the solution set here, the feasible set. We'll start with x is less than 80 here. Okay, so x is less than 80. That's given by, okay, so that's given by here. Okay, x is less than 80. Okay, so this line is x equals 80 here. And then remember that our convention is that we shade the region that's not part of the solution. So this part is part of the solution because everything, all your x's are less than 80 here. But so but that is the solution. So we're going to cross this side out. So we're going to start crossing this side out. Okay, so crossing it out. Okay, and if you have colors, this is the best time to use it. If you don't have colors, what's nice is if you shade perpendicular to the line here. This is the line x equals 80. So just to be clear, x equals 80 here. Okay, and then just shade perpendicular. Okay. All right. Now let's quickly graph the other ones here. So we started graphing these ones over here, and we'll do them right now. So let's start with the 10x plus 12y is less than 1320. Okay, so I'm going to write that down here. Okay, so 10x plus 12y is less than or equal to 1320. Okay, and what you can do is you can use the, as we did yesterday, so I'll just repeat it here. You can use the intercepts method here. Okay, so x equals 0 to graph the line. So x equals 0, that gives you 12y equals 132. That gives you y equals 110. Okay. Oh, I'm sorry, not 110, 11. Okay, so this is your well, x equals 0, so this is our y-intercept, which is 0, 11. This is the y-intercept. Oh, I'm sorry, I'm still a little bit tired right now. This should be a 1320 here because x equals 0. That means you just have 12y equals 1320. Okay, so this should be this is 110 here. Okay, so this is our y-intercept is 110. Okay. Okay, so sorry about that. 110 here. 110 is about here-ish. Okay, and then to find our y-intercept, we set y equals to 0. Okay, y equals 0. We get we get 10x equals 1320. Okay, so this here we have to think a little bit. This would just be 132. Okay. Okay, so our x-intercept is 132, 0. Okay, so if you did this already, thank you for waiting here, but we'll just quickly graph that. You'll need a ruler, so use your ID card or use a ruler to the best of your ability. Now, because I did 20s here, you can just take the middle, that's 130, and then a little bit to the right is about 132-ish. Okay. Okay. And as we've done before, you now have to check a point, but as we saw the pattern in class, as some of you pointed out, that the less than region is going to be below the line, okay? And that is correct when you have a positive here, and usually that will be the case. But usually you should check. So a 0, 0 is part of the solution. That's easy to see here. So that means the other side of the line is not part of the solution, so we're going to cross it out, okay? So again, if you don't have colors, what you can do is just do this perpendicular motions here so you can get the cross hatching here so it's easier to see, okay? And remember, our convention is to cross out the side that's not part of the solution, okay? So this above part is not part of the solution, okay? The line can be drawn longer just to be clear if you want to. So this is not part of the solution here. Okay, so now let's quickly draw the other one, and I'm going to use blue for this one. The other line here is 15x plus 10y is less than 1500. Okay, so we'll quickly write that down. So I'm sorry, I think I said that wrong. 15x plus 10y is less than 1500. So 15x plus 10y is less than or equal to 1500. Okay, and we can do the same game here. Okay, so I'm just going to quickly I'm just going to write down the x and y intercept so we can get going here. The y-intercept here turns out to be, it's not too hard to see, x equals 0, that's the y-intercept. So that means that 10y equals 1500. You cancel out the 10, you get y-intercept is 150. So this one's not too bad. The x-intercept is also not too bad. Y is 0 now. Okay, so I don't know if I can do this. Y is 0. So that means that 15x equals 1500. So then you just get 100. Okay. Okay, so that one's not too bad here. Okay. So this one will be nice. It's on the tick marks here. And what we will get is something like this. Okay. Okay, so we'll draw the picture now. Okay, so now again, as the pattern, the way the pattern works. Okay, so again, remember this line here is when you have equality. So I'm just going to label that. Okay, so the way it works is that everything below is part of the solution, but you have to, in general, you should check a point. So 0, 0 does not work. It does work. 0, 0 does work. Okay, so that means this part is the solution before the line, below the line. So the other side is where we shade. Okay. In general, you should check, and there's always a way of checking. Okay, you test a point. Okay. And then if it works, shade the opposite side. If it doesn't work, then shade that side. Okay. Okay. Great. Okay. So I'm going to take a second and just make sure we shade in the regions nicely. I'm also going to label this green line here. This is 10x plus 12y equals 1320. Okay. So 12y equals 1320. Okay, and so our feasible set now is going to be this region here. Okay, this region here. Now remember, we also have these free inequalities here that we should really include. So really, if we're including x is greater than 0, then we shouldn't have this part here. Okay, so we should cross this part out. Okay, so I didn't mean to cross that out. And then we should also cross this part out as well. So I'll just use this purple to cross this part out. All right. Okay, so now that we have the feasible set here, we're going to use the fundamental theorem of linear programming, okay, which says, it says that the maximum or minimum values of the objective function is achieved at one of the vertices of the feasible set. Okay, so that means that, let's go back to our picture here, that means that our maximum of our profit function will exist at one of these vertices here. Okay, so the thing is, is that the theorem doesn't tell you which one is the maximum or the minimum. It just says that it occurs at these vertices. Okay, so we have to be careful, a little bit careful here. Remember, the feasible set is the solution set to these constraints here. Okay, so by our way of shading things in, we cross out the parts that aren't part of the solution, that are not part of the solution. So the blank space is our solution. Okay, so I'm going to try to zoom in here, and I just want to sort of show that it's a little hard to see, so I'll let it focus for just a second. You can see that there's like this little triangle here that's not part of the solution. Okay, so we actually have a few vertices here. So I'll use maybe I'll use pink to mark the vertices here. We have a vertice here, okay, and then we have, it's hard to see, but you have one vertice here, and then you have one vertice here, okay, one vertice here, and you have one vertice here. Okay, so on Desmos yesterday, we found the coordinates using Desmos. Desmos graphing calculator helped us find the coordinates. But now what we're going to do is we're going to solve for all these vertices using algebra, okay? And what we could do, I mean, this vertice is kind of easy to see. This one's just 0, 0. Not too bad to see. But we can immediately say that this is not the maximum, because 0, 0 means that you're not going to make any radios, and instead, and hence not make any profit. So this would be a minimum here, okay? So what we need to do is figure out these vertices here, okay? And we want to write them all down, okay? So I'm going to make sort of a table here, a second table here, and I'm going to be so sort of our possible xy's, okay? Possible xy. We're going to make a table here. So we already have one. Okay, this is just 0, 0. Okay, and then we have to find the rest of these. So this one, this one, this one, this one. So we have 5 here. 4 more we have to find. And then here we're going to put the profit. Okay, and here this p, we're just plugging. Eventually, we'll plug these into here, the profit equation. Okay, and whichever is the biggest profit will be our answer. Okay, so here this is 0, okay, because if we put 0 into here, we're not going to make any money. So if you make no radios, Model A or Model B, none of them, $0 profit, okay? So we need to now solve for these, but this is where we need to do some algebra here, okay? Now, as you're doing these at home, what you want to do is to make sure you label the lines, because you can see that these vertices are intersections of lines. Okay, so for example, this one's not too bad. This is the green line, okay, intersected with the y-axis. Now the green line here, we said earlier, is this 10x plus 12y equals 1320. Okay, so what you can do is you can set up a linear system here. So this vertex here, so actually, why don't I just label a couple of these here, so it'll be easier to remark. So this is A. Oh, I should have used pink, but that's okay. A, B, this one's C, and then this one's D here. Okay. Okay, so those are our 4 other points. We got A, B, C, D, and we got to figure out what they are. Okay, so A is the intersection of the green line and the y-axis. Okay, so on this is where you need that separate piece of paper. So if you're using the handout that I had, that's why I had that blank piece of paper available there. This is where we need a separate piece of paper. Okay, so the point A, whoops, let me get this straight here. The point A, well, that's the green line intersected with the y-axis. So the y-axis is x equals 0. That green line is this first inequality, or the second inequality here, 10x plus 12y is less than 1320. All right, so oops, let me use green here. 10x plus 12y is equal to 1320. Okay, so that's the equation of the line. The inequality is the region. okay, or sorry, the region that's not shaded, okay? Okay, so now we can solve the system, but the system's not too bad to solve. This one's not too bad to solve. All we just have to do, well, x equals 0, so that means you got 12y equals 1320. And then y equals 1320 divided by 12. So 1320 divided by 12 is 110. Okay, so as you can see, this point we actually solved already. I mean, you probably already see this already. It's this intercept. It's the y-intercept. It's this 0, 110. Okay, so A was not too bad to figure out. Okay, so this is 0, 110. Now, D is also not going to be too bad to figure out as well. D is where this vertical line intersects the x-axis, which is 80. X equals 80. So that one's not too bad to figure out as well. Okay, now the ones that we have to think about is B and C, and how are you going to get B and C? Okay, so B, okay, and this is where if you have colors, I'm sure you all have a lot of good things at hand here. B and colors will help you sort of separate which lines are not. If not, what you have to do is just make sure you draw the picture very well, okay? Okay, and then technology also helps too. So I'll show you how you can do this on technology later on. So you can see that B is going to be this blue line intersected with the green line, okay? So blue line, what's the blue line? Blue line is 15x plus 10y equals 1500, okay? So 15x plus 10y equals 1500. And then the green line, again, is the green line, okay? So 10x plus 12y equals 1320. Okay, and B is the solution to this. So B is the x and y that satisfies this linear system, okay? And now we have options here. You have your Gaussian elimination, you got your addition method, you have write this as a matrix equation and find the inverse and multiply this part by the inverse matrix. We have options here. There's a lot of things you can do. For the sake of just doing this out, I'm going to use, I don't know, let's see. Substitution is not a really good one here because I don't really want to solve. Let's just maybe use Gaussian elimination just so we can review that, since we did all that work for Gaussian elimination. So we're going to take a second and solve this now. Okay, so Gaussian elimination, we have 15, 10, 10, 12, okay, and then 15, 0, 0, and 13, 20, 0, okay. Okay, so, okay, that's what this is over here, okay. So now what we can do is, we want to make this part 0, but I also would like this to be a 1. So maybe we could try to divide by 5, since these all have a common factor of 5. I don't know. 3, 2, okay, and then 15, so what did I do? Divide by 5, so that will be a 300, okay. And this is a good time to have a calculator on hand to do some of these computations, if you need one, okay. Okay, and then this one we can divide by 2. So divide by 2, this will be 5, 6, and then 1320 divided by 2. Should be able to do that, but whatever, 660. Okay. Okay, so we want to make this 0, so we could just multiply this one by 5, which is exactly this here, or kind of undoing it, okay, and then multiply this one by 3. Okay, so this is probably not the fastest way of doing it, but whatever. Okay, so if we multiply this by 5 here, we'll get 15, 10, 1500. We get back what we just multiplied here. And then if we multiply this one by 3, well, we get 15, what are we doing? By 3, so this is 18. And then 660 times 3. So 660 times 3 is 1980, okay? So, and then we have the option of subtracting here, okay? So normally we could say this minus this, but because if I do this minus this, then we won't have negatives, okay? So and we'll avoid negatives, okay? So again, I'm going to keep the first row the same, but the second row transforms into 0. 18 minus 10 is 8, and then 1980 minus 1500. Okay, 1980 minus 1500. Okay, so that is, so if you can't do that in your head, that's okay. That's why the calculator's there, okay? We get 480, okay. And this now, we'll be able to now solve this nicely using, okay, so we can put this back into diagonal form, but if we keep going just for a second here, okay, so 48 divided by 8 is just, what is it, 6? Yeah, 60, so 480 divided by 8 is 60. So now we know that the y is 60, okay? So at this point here, you could keep going with the Gaussian elimination. Since I've been going along, I'm going to just do that. I'm going to multiply this by a -2 or a 2, okay? And that will be a 120, okay? And then now, okay, so we're going to add, so this will just be a 3, and then 0. This is all the same here, okay? And then we're going to do 300 minus 120. Okay, so if you want to do my trick, 300 minus 120, so 120 to 200 is 80, and then 200 to 300 is 100, so that's just going to be 180. Okay, so not too bad here. This one don't need a calculator. Okay. Okay, and then we just divide by 3. Okay. 1, 0, divide by 3, that's 60. Okay, 0, 1, 60. Okay, so this might have not been the fastest way, but now that we know the solution here, we know b is, so x, y equals 60, 60. Okay. All right, so now we know what b is. Okay, so it's 60, 60. Okay, so let's go back to here, and we know that b is 60, 60. So we saw this yesterday, if you watched the video, but now we know this is 60, 60. Okay. Now let's take a second and solve for c. Okay, so if you want to, you can just pause for a second and try to solve for c. Okay, and then you can watch me do it. Okay, so I'll give you a second to pause. Okay, so c, if we look closely here, this one's not going to be that bad because it's going to be the blue line and the red line intersected with each other. So blue and red, okay, well, so on my piece of paper here, so this is my scratch work here, so it's a little bit, I apologize, I wrote from right to left, okay, because I'm left-handed, so this is a little bit more natural for me. But C, it's going, what did I say? It's the red line intersected with the blue line. Okay, the blue line is the 15x plus 10y equals 1500. Okay, and then this red line is easy. It's just x equals 80, okay? So x equals 80, okay, so, well, we just plug that into there, and then we can solve for y. Okay, so nothing to it there. Okay, so 15 times 80, okay, plus 10y equals 1500. Okay, so now we just have to solve this, and then we'll be done. So 15 times 80, okay, so that's 80 plus, or 80 plus 40, which is 120, so I think this is 1200, okay, plus 10y equals 1500. Okay, if we subtract the 1200 on both sides, okay, this will just be 10y equals 1500 minus 1200, so that's just 15 minus 12, so that's 300. And then you get y divided by 10, so that would just be 30. 30, okay. Sorry, I was getting distracted. This is an easier way to do 15 times 8. 15 times 8 is the same thing as 15 times 2 times 4. So 15 times 2 is 30, so 30 times 4 is 120, and then you have a 0 here. Anyway, so the point here, okay, is x equals 80, y equals 30. Okay, so we have our final point here, okay, 80, 30. Okay. Okay, so if, at this point, if you're okay, so feel free to pause, okay, if you have any questions. You can rewind and look back. But now we're going to go to the last step. The last step is, okay, what's the last step? Whoops. The last step is to, well, we just have to check the maximums and the minimums using the objective function, okay? So literally this just means take these possible x's and y's that the fundamental theorem of linear programming said were the possible maxes and mins. Okay, so take these and plug them into the profit function, the original profit function here, okay? And then we just have to check to see which one's the biggest, okay? So this is where having a calculator is helpful, but some of these aren't too bad. So this one, 0, 0, is not too bad here. We're going to plug this one into the profit function. Let me circle the profit function so it's easy to see here. Okay, and well, you're just going to have 0 times 12, which is 0, okay, and then plus 10 times 110. Now multiplying by 10 is easy. You just put another 0 down. So this is just going to be 1,100 or 1,100. Okay, so that one's not too bad. Okay, this one's also not too bad too. You do 12 times 80, okay, plus 10 times 0. So 10 times 0 is 0. So 12 times 80, okay, so you just have to do 12 times 80. So 12 times 8, that's 96. So you have 96 with another 0. Okay, so you're going to have 960 here. Okay. Okay, now here you might need a calculator, but if you're good at the mental math, I'm not going to stop you, but I'm just going to use a calculator. Okay, so you have 60 times, oops, let me try again, 12 times 60, okay, plus 10 times 60, okay, so that's not too bad. So that's going to give you a 1320 here, okay. Okay, and then you get 80, oh, and just got a little bit blurry here. Okay, so 80, okay, and 30, so 12 times 30, or sorry, 12 times 80 plus 10 times 30, okay, and that's going to give you a 1260. Okay. 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 And so now the answer is, okay, well, the answer is just whatever's the biggest. Okay, so the biggest here is 60, 60, 13, 20, and that's it. Okay, so this is the biggest. Okay. Okay, so, and we finished C now. So the answer to C now is this corner point, B, gives us the maximum profit here. So by the way, this 1320 doesn't have anything to do with this 1320 here, okay? This 1320 is money. This is cash money, okay? But this 1320 was how much time is available on here, okay? It's just a coincidence that these two constraints look very similar, okay? But okay. All right, that's it. Thank you for watching. If there's questions, put them in the comments below, and I will be happy to answer them. Okay, bye-bye.